Hey guys, welcome back. For this video, we're going to finish up the second half of Intercepts of Graphs with it, which is lesson 3.4. The lesson, of course, is going to be, or the goal today is going to be to solve equations by graphing. And we're also going to talk about the vocab of root and zero, and you're going to find out they mean the same thing, which is solution. Okay, so for the learn section here, it says solving equations by graphing. The solution or root of an equation is any value that makes the equation true. A zero is an x-intercept of the graph of that function. For example, the root of 3x equals 6 is 2. A linear equation like 3x equals 6 has at most one root, while a nonlinear equation like x squared plus 4x minus 5 equals 0 may have more than one root. So down here in this table we have 3x equals 6, but we're going to write it in function form, which would look like this. You'll notice that what has happened from the original equation is the 6 has been eliminated from one side and moved over to the other side with 3x. And we do that on purpose. And again, we could have also wrote that as y equals 3x minus 6, which looks like a traditional linear equation. Same thing down here on this one, where the equal to 0, and I said before that we try to force our equation to equal 0 when we solve quadratics, so we can do that with linear equations as well, determinant functions. And all we do is we replace the 0 with the f of x, and now we have function form. Let's take a look at down here where they actually make the transformation. So 2 is the solution of this equation because 3 times 2 equals 6. We also refer to it as the root, so the root is also another name for solution. When we take this 6 and we write it on the other side and make the equation equal 0 like this, then we just replace the 0 with f of x form. Then it looks like this, and the solution is still 2, but now we call it a 0 because if we were to input a 0 in for f of x, this whole equation would output a 0, and that's why we call it the zeros of the function. So we've got solution, root, and 0, and those are all the same thing. But also on a graph, if I were to go and graph this function, this graph will cross at 2, which is the x-intercept, which is also the solution for the same function. Example 5, we want to solve a linear equation by graphing. So in order to do this, and especially if we're going to use the Desmos calculator, you have to make your equations equal 0 and then substitute f of x or y in place of that 0. So this particular problem here, we're going to subtract 1 from both sides. And that will leave us with a 0 on this side, and of course 7 and minus 1 will make a positive 6. So our function that we're going to graph will be this here, except we're going to replace 0 with f of x. So f of x instead of 0 there. And we write the rest of the equation, or the rest of the function, which is negative 2x plus 6. And then we go and graph this. And when we pick a value of x that causes the output to be 0, that's where the x-axis occurs. That's also called the solution. So if we take a look at the graph, we can see that the graph has an x-intercept right here, and that x-intercept is at 3, 0. So the graph intersects the x-axis at 3. This is the x-intercept, or 0, which is also the root of the equation. So the solution of the equation is 3. So if we look back up to the problem, which is right here, and we substitute a 3 in place of x, you can see we end up with negative 6 plus 6 ends up equaling 0. So it's the 0 of the function, meaning 3 is the solution. Example 6, solve a nonlinear equation by graphing. In fact, most of our nonlinear equations, we do this anyway. We force it to equal 0. So the first thing we're going to do on our equation, which is here, is to get rid of the minus 3. So we're going to add 3 to both sides so that we end up with a 0. So when we go to solve these by graphing, our objective is to make this equation equal to 0. Then all we do is we substitute 0 with f of x, and that would give us f of x equals x squared minus 4x plus 3. Now remember, we're looking for where the graph crosses the x-axis. And at the x-axis, all the y values are 0. That's why we're making this thing equal 0, which is going to end up being the y value, and we replace it with f of x, which is what we want it to do because we want to find the x-intercept, which is the solution. So let's take a look at our graph here. They went ahead and graphed it for us, but we could have gone and made a table of values and then inputted those points and see that it actually creates a curve. But they gave it to us. So right here, we have an ordered pair, or an x-intercept, and over here we have another x-intercept. So this quadratic ended up having 2 intercepts, meaning it'll have 2 solutions. So the graph intersects the x-axis at, it looks like 1, and again at 3. These are the x-intercepts, or zeros, which are also the roots of the equation. So the solution of the equation are 1 and 3. I think they may have wanted me to put 1, 0 and 3, 0 up here as an ordered pair, but we're only interested in the x-coordinate on that problem. That means if I were to substitute those two numbers in for x into the function, it should give me a 0 output, which is the actual intercepts. So what it will do there is actually substitute them in. So I'm going to substitute a 1 in for x. 1 squared is 1. Negative 4 times 1 is negative 4 plus 3. You'll see when I add these up, it does give us a 0. I'm going to do it again by substituting a 3 in. So 3 in for x. So 3 squared and then minus 4 times 3 and then plus 3. 3 squared is 9. Negative 4 times 3 is negative 12 plus 3. And negative 9, or 9 minus 12 plus 3 is still going to give us 0. So you see there's actually two solutions to this problem. Example 7, solve an equation of a horizontal line by graphing. And if you remember what I said in class, a horizontal line should end up being equivalent to y equals some constant value. No x in the problem at all. So taking a look at this equation, we want to eliminate everything on one side so we have a 0. So the first thing we're going to do is maybe get rid of the 5. I would normally get rid of the variables, but they're getting rid of the 5 first. So that would give us a 4x plus 8 on this side. This, of course, zeroes out. Then we're going to get rid of the 4x on the right-hand side, so minus 4x and minus 4x. And the right-hand side becomes a 0. And the left-hand side becomes a 0 plus the 8, which leaves us 8 equals 0. Now, if you remember what we talked about solving equations, multi-step equations before, if we end up with an equation like this where it's not true, 8 equals 0 is not true, there should be no solution. But they want us to graph the left side of the equation, so they're saying graph this right here. So we're going to call this y, or f of x equals 8. And that's like saying y equals 8. When we graph that, we get this horizontal line up here, which is right here. And you'll notice that it doesn't cross the x-axis. This means that there is no x-intercept, and therefore there is no solution. But of course, we knew that way back up here. Go ahead and pause the video and attempt to check here. Okay, for this example, they want us to take each equation, write it as a related function, and then find its zeros. Okay, so we got the equation right here for the first one. You see it says 2 equals 1/2 of x. In order to put it in function notation, you have to make the thing equal 0. So I'm going to subtract 2 on both sides, and that will give me 0 equals 1/2 x minus 2. And then all we're going to do to put this in function form is replace that 0 with f of x, because remember, the solutions are where the output equals 0, so we want the y values to equal 0, so we're replacing that with our y equivalency, which is f of x. So the related function is f of x equals 1/2 x minus 2. Now if I go and graph it like they did, we can just look to see where the intercept is, which is right here. And the intercept there is at 1, 2, 3, 4. It's at 4, 0. So the 0 then is actually 4, because if we input a 4 into this function, it outputs a 0 for the problem, which is actually the answer to our original equation. The second one here, we want to subtract things from one side, so I end up with a 0. So how about we subtract the 2 first? So 3x, and if I subtract 2 from my 7, I end up with a plus 5 is equal to 3x. Then I subtract 3x from both sides. When I do that, I end up with 5 is equaling to 0. And again, in place of this right here, we're going to substitute that with f of x. So f of x equals 5, which again is the same thing as saying y is equal to 5. And if you remember, that's actually going to create a horizontal line, which you can see it clearly creates a horizontal line. So the equation here would be f of x equals 5. And you'll notice that it doesn't cross the x-axis anywhere. So what are the zeros? Well, we would say there is no solution. Or you could also use the empty set or the null set symbol as well. The next one here, we want to force this to equal 0. You'll notice that the equation they have has 2 numbers on the left-hand side and only 1 on the right. So I suggest eliminating x from both sides. And the way we're going to do that is subtract x from both sides. And when I do that, the x squared will come down as it is. And this x, when I subtract from both sides, will end up being a minus x. Then I also have the minus 6. And now on the right-hand side, since I eliminated this x, I now have a 0. And all we got to do is replace this with f of x, and that's our equation or our function. So the related function here is f of x is going to equal, and I'm just using the symmetry property here to swap these around, flip them around. So f of x is equal to x squared minus x minus 6. All right, so now we got to find the x-intercepts. It looks like one of them is right here, and that appears to be a negative 2. And the other one is over here, and that appears to be halfway between 2 and 4, which I'm going to say is 3. And you can always check to see if your zeros are correct, because if you take them and substitute them in here and here, this thing should output a 0 on that side. And I'll go ahead and check that real quick. So I have negative 2 squared minus negative 2 minus 6. So negative 2 squared is 4. Negative times the negative 2 is going to give us a positive 2 minus 6. So you can clearly see that's going to equal 0. Okay, so now I'm going to do the same thing with the 3. So put a 3 in there and square, minus 3, and then minus 6. So 3 squared is 9, and negative 1 times 3 is negative 3, or minus 3 minus 6. You can clearly see that's going to also give you 0. So our solutions here do work.